So at its core, division is multiplication in reverse. Every division problem hides a multiplication problem. Let's take 3 times 4. This gives us 12. Now if we did 12 divided by 3, we get 4. Let's do 2 times 2, which gives us 4. Now if we did 4 divided by 2, we get 2. Do you see the symmetry? So in multiplication, 3 times 4 looks like 3 plus 3 plus 3 plus 3. Because what multiplication is asking is it's taking a number and it's adding itself multiple times. And what division is asking is if we're doing 12 divided by 3, how many steps did that take? Well, that took 4 steps. Now let's say I have 12 dots. I am going to make groups of 3, and then I'm going to ask, how many groups do I have? Alright, so here's one group of 3. Here's another group of 3. Here's another group of 3. And another group of 3. This is group 1, group 2, group 3, group 4. So I have 4 groups. This is the same thing as 12 divided by 3 equals 4. So division is also counting how many groups can fit. Can you think of any situations, real or abstract, where this idea appears? Let's say we have a square, and I divide this square up into 4 tinier squares. Also, here's some food for thought. Just this one square would be 1/4. We'll dive into fractions in another video. But if I were to group groups of 2, how many groups would I have? So here's one group of 2, and here's another group of 2. So I have 2 groups. And this is the same thing as 4 divided by 2 equals 2. There are cases where it won't be perfect. An example of this is 1, 2, 3, 4, 5, 6, 7. I have 7 dots, and I want to group these into groups of 2. So here's one group of 2, here's another group of 2, and another group of 2. But this little guy is alone. He doesn't have another friend to be grouped with. So, in this case, I have 7 divided by 2 equals, I have 1 group, 2 groups, 3, remainder 1. It can also be this. which is the same thing as this. But we'll get into that in another video. Alright, let's do some long division. 1,547 divided by 7. There's no way we can make 1,000 dots, right? So then what happens is we do long division. So we make this bar here, and in here we put the dividend, is what it's called. Out here we put the divisor, and our answer is called the quotient. And if we don't get a perfect quotient, then we have a remainder. So in this case, 1,547 is my dividend, my divisor is 7, and now we need to find the quotient. So I know it's a really big number, but trust, we're going to work through it. And yeah, so the first question is not how many times can we put 7 into 1547. That is the ultimate question, but we don't know that off the top of our head, so we need to start small. Can 7 go into 1? It can't. Can 7 go into 15? It can go into 15. It can go into 15 2 times. And 7 times 2 is 14. So we're going to subtract 14 here. And 15, but it's only asking this part right here. 15 minus 14 is 1. And then we bring these down. And then we ask, okay, does 7 go into 1? No. Does 7 go into 14? Well, it does, because 7 times 2 is 14, so then we put the 2 up here. And then we subtract again, although this time we're only looking at these. And 14 minus 14 is 0, so we only bring down the 7. And what do we know? 7 times 1 is 7. So we put the 1 there. And our answer is 221. Now let's do a problem where we do get a remainder. Alright, so I know 5 can't go into 3, but it can go into 34. I know 5 times 7 is 35, but that's too big. 5 times 6 is 30. So that is what we're going to use. So we're going to subtract 30 here. We're also going to put 6 up here. And 34 minus 30 is 4. And we bring down this 7. Now 5 can't go into 4, but it can go into 47. 5 times 9 is 45. So we're going to put the 9 up here. We're going to subtract here, and we get 2. Now, we don't have anything else to bring down. We simply have to put 5 into 2, but we can't do that. So then what happens is we have a remainder of 2. Alright, here are some example problems for you guys, and the answers will be at the end of the video.